Hello. Today I'm going to talk to you about the evolution of atomic theory, which is basically just our understanding of what the atom looks like and how that's evolved over time. So the concept of the atom, which is that matter is indivisible once you get to a certain point and that there's a smallest unit for matter, was first, the term at least, was first coined in Greece in 465-ish BC by a philosopher named Democritus, and he chose the word atom because the derivation of that in Greek is indivisible. All right, so then over time, other scientists made observations about the atom and used those observations to describe what the atom would look like. So Dalton developed the atomic theory in the early 1800s. Thomson developed the Plum pudding model for the atom in the early 1900s. We're going to talk about his model and Rutherfords model, which was developed a little bit later. Rutherford was a student of Thomson. And then in the next unit, we will talk a little bit about the Bohr model for the atom. And if you take AP chemistry, we'll spend some time talking about Schrodinger's model for the atom. All right, so today I'm just going to focus on Thomson and Rutherford because I think it will help you understand the structure of the atom and how we got to the model that we use today. All right, so Thomson originally proposed this plum pudding model for the atom. And we don't really eat plum pudding in the United States, but you can kind of think of it like a blueberry muffin or a chocolate chip cookie, something like that, that's spherical. So here we have what that might look like from his perspective. So the majority of the atom is made up of positive charge. We knew that. We knew that the mass of the atom was mostly from protons. All right, and that there were electrons in there which had negative charges, but that they were a very, very small portion of the mass. So he proposed this model that most of the atom is the cake-like part of the muffin, and then the little flecks inside, either blueberries or chocolate chips or whatever kind of muffin you have, are the electrons, and that they're sort of interspersed throughout evenly. So if we were to draw this in two dimensions, basically all the orange is positive charge, and then we have these little blue electrons scattered throughout. So Thomson's student Rutherford designed this experiment that he was going to do using gold foil. So he had a source of radiation, which was alpha particles, and he is going to shoot those alpha particles at a very thin sheet of gold foil. Right? And if Thomson's model is correct, what he thinks is going to happen is that the alpha particles will all go straight through, okay? Because the atom is mostly this diffused positive charge. All right, so he did the experiment, and what he found was that most of the particles did go all the way through, just straight through, as if there wasn't even anything there. But sometimes the particles were deflected, all right? So they could have been deflected at like 90 degrees or straight back, or, just a small angle deflection, right? And this screen here basically acts as a detector for the alpha particles that are coming through. Right. So based on the results of his experiment, he modified the model of the atom. So over here we have in red the positive charge, in blue the little dots of electrons in there. This was Thomson's model, and like I said, what Rutherford expected to happen if that's what the atom looked like is that all of the alpha particles would just go straight through because of that diffused positive charge. Right. However, what happened is that sometimes the alpha particles bounced back. Okay, and he hypothesized that this meant that the positive charge must actually be in the middle of the atom in a very densely packed center. Right, so he called this the nucleus, said that's where most of the mass for the atom would be, and that's where the positive charge would be, because the alpha particles have a positive charge, and so if they get close to a really dense positive charge, they're going to deflect. Right, because two positive charges will repel each other, right? And then he said that the electrons must be around the nucleus, making up the rest of the volume of the atom, basically, but that it was mostly empty space because we know that the electrons are very small and don't take up a lot of mass. Okay, so that was his explanation for most of the particles going straight through, but the ones that bounced back, he said, must have hit this dense center, which he called the nucleus. All right, at this point in time, we don't yet know anything about neutrons, and in the next video, I'll talk to you more about the different subatomic particles. All right, but this is the experiment that led to the conclusion that there's a dense positively charged nucleus in the middle of the atom.